Hey guys, today we're going to go on to the next section, which is operations with radical expressions. So now that we know how to simplify a radical, we can actually do some operations, which is going to be addition, subtraction, or multiplication. So we're going to learn how to add, subtract, or multiply with radical expressions, and we're going to use what we already know about simplifying. So let's go ahead and see what we need to do here. To add or subtract radicals, the rule is the radicand's number under the radical. So the radicands must be the same. Simplify if necessary, and then combine like terms. So if we go ahead and look at the first question that we have, 7 radical 2 plus 3 radical 2. The radicands must be the same, and they must be simplified. So is radical 2 simplified? It is. Is radical 2 on this side simplified? It is. So keep the like radical, do what the numbers ahead of them say, 7 plus 3. That is where we got 10 radical 2. The next one is not as easy, because if you notice, the radicands are not the same. So ask yourself, can I simplify these radicals in hopes that I can then get them to have the same radical so I can actually go ahead and subtract like it's asking me? So 27, it's not a perfect square, but ask yourself, what two numbers multiply to give me 27, one of them being a perfect square? And it is radical 9 and radical 3. Minus, can this be simplified at all? That radical cannot, so I'm just going to leave it. I'm going to keep simplifying here from that radical 27. So the square root of 9 is 3. The square root of 3, I don't know what it is, and I can't simplify it any further. I already said this side was already simplified, so I just need to bring it down. Now that these are both simplified, now can I subtract them? Now do I have like radicands? Or are these the same? They are. Keep the radical, do what the numbers ahead of them say. 3 minus 2 is 1. Notice, they didn't put a 1 in front of the radical. That's like not putting a 1 in front of your x. You know it's there. If you put it, you're not wrong. If you don't put it, you're also not wrong. All right, let's go ahead and see how we can subtract these. So 9 radical 5 minus radical 5. Let me ask you, what number is in front of this radical if I don't see it? We just talked about it over here. I would put a 1 there if I were you, so you don't make this mistake. Now check to see, in order to subtract, you have to have like radicals. Do you have like radicals? You do. Keep the like radical. Do what the numbers ahead of them say. 9 minus 1. Well, what is 9 minus 1? It is 8 radical 5. That's my answer. This next one is asking me to add and subtract. So it's asking me to do more than one combination, which is fine, but I have to have like radicals. And clearly, I do not have like radicals here. Well, let's see if we can simplify in order to get like radicals. So let's look at 2 radical 8. Can you simplify radical 8? Leave the 2. What 2 numbers, radical 8 is not a perfect square, but what 2 numbers multiply to give me 8? One of them being a perfect square. Very good, radical 4 and radical 2. Leave the 2 that was out front. What's the square root of 4? It's 2. The square root of 2, can I find it? No, so leave it. So this whole first part gives me 4 radical 2. So I went ahead and multiplied my like terms. Now I have a plus sign. Now I'm going to do the next part, the 5 radical 2. Is that radical simplified as much as possible? And it is, so I can bring it right down here. I can't simplify it anymore, so I would just leave it as it is all the way through. Now I've got subtraction, and let's see what we're left with over here. Radical 18. Is 18 a perfect square? No, it's not. So ask yourself, what 2 numbers multiply to give me 18, one of them being a perfect square, so I can go ahead and simplify. And it is radical 9 and radical 2. What's the square root of 9? It's 3. I lose the radical when it's a perfect square. What's the square root of 2? I don't know, and I can't simplify it anymore, so leave it. So now look at what I'm left with. Yes, I had to do some work to simplify. It wasn't hard, but I had to make sure each one was simplified. Now, do you have like radicals? Yes. Keep the radical. Do what the numbers ahead of them say. Since it's addition and subtraction, I'm going to go from left to right. 4 plus 5 is 9. And then 9 minus 3 is 6 radical 2. And I have my answer. Could I very well go ahead and check my answer in the calculator? Let's see if it'll work. All right, so the question was, I'm going to put that whole big long question in. 2 radical 8 plus 5 radical 2 minus radical 18. Get an answer, I'll get some crazy decimal. Now use my answer that I got and see if I get the same decimal equivalency. 6 radical 2. And notice I get the same decimal equivalency, so I know that my answer is right. Now, these didn't have any variables, so I could check myself on the calculator. When you can, do it. It makes your life much easier. So that is addition and subtraction, using all the things we know about simplifying. And then everything we know about combining like terms. Let's go ahead and look at multiplying. To multiply any two radicals, multiply the coefficients. Remember, those are numbers in front of a variable, or in this situation, numbers in front of a radical. And then multiply the radicands. Simplify afterwards if possible. So, look at what I have here. 3 radical 2 times 4 radical 3. The 3 and the 4 are coefficients. They're numbers out front of the radical. So I put those together and multiply them. 3 times 4 gave me 12. The radicals, I put those under one radical and multiply them. 2 radical 3 is 6. Now ask yourself, can I simplify this any further? Is 6 a perfect square? No, it's not. Can it be broken down any further? There are 2 numbers that multiply to give me 6, one of them being a perfect square. And no, there isn't, so that is why that is my answer. What we got for the next one? 3 radical 5, and I want to square it. Whenever you square something, it means that thing times itself. Write it out and show your step. Multiply the coefficients. The coefficients are my 3s. They're out front of the radical. Those go together. And then the radicals go together under 1. Then finish multiplying. 3 times 3 is 9. 5 times 5 is 25. Can I simplify afterwards? Leave my 9. What's the square root of 25? And it's 5. I lose my radical. So I could simplify and now keep going further. 9 times 5 is 45. All right, on to number 3 and then number 4. Number 4, we'll throw a little geometry in there, so we'll get to that in a sec. But number 3, 5 radical 6 times 3 radical 2. Organize it. Coefficients get multiplied together and radicals get multiplied together. Coefficients are the numbers out front of the radical. 5 times 3, radical 6 times radical 2. Finish. Put together like terms. 5 times 3 is 15. These 2 go under 1. So 6 times 2 is 12. Ask yourself this before we stop. Is this simplified? Is 12 a perfect square? No, it's not. But what 2 numbers multiply to give me 12, one of them being a perfect square? So I need to break that into radical 4 and radical 3. Leave the 15 out front. The square root of 4 is 2. The square root of 3, do I know what it is? No. Can I break it down any further? No. And finish. Like terms, 15 times 2 is 30, radical 3. Check myself on the calculator. Put in my question and put in my answer and make sure they have the same decimal equivalencies. So 5 radical 6, use your over arrow, times 3 radical 2, hit enter. go ahead and put in my answer. And I should very well get the same decimal equivalencies. And I do, so I know I'm correct. On to that last question. That deals with some geometry. Find the area of the rectangle. Let me ask you this. Area of the rectangle. What is the area formula for a rectangle? Length times width. Substitute with my length and my width is. So, doesn't really matter which one you put where, because aren't we multiplying them together? 4 minus 6 radical 2. Now how am I going to multiply this length and this width? This is one term and this is two terms. Your length gets distributed to each thing inside of this parenthesis, because each part needs to get multiplied by radical 3. So, radical 3 times 4. Remember, there's a 1 here, so 1 times 4 is 4, leave the radical 3 at the end. You can add or subtract if they're, you can multiply if they're not like radicals, you just can't add or subtract. Minus, for my sign, radical 3 times 6 radical 2. Remember, the coefficient's 1 here. So 1 times 6 is 6. Radical 3 times radical 2 is radical 6. Now, let's check to make sure I can't simplify any further. 4 radical 3 is 3 a perfect square. It's not. Can I break it down any further? I cannot, so leave it as 4 radical 3. Minus, can I break this down? 6 is not a perfect square. Can it go any further? Nope, so leave it. That whole thing is your answer. They're not like terms. I don't have like radicals and I can't simplify them, so I'm done. Check yourself on the calculator. Put in my question right here and put in my answer and make sure my decimal equivalencies are the same. So, radical 3, open the parentheses, use your over arrow and then open the parentheses. 4 minus 6 radical 2, use the over arrow and close your parentheses. I get, let's see if I get that for my answer. My answer was 4 radical 3 and 6 radicals, minus, sorry. Put that minus in, minus 6 radical 6. And I should very well get the same decimal equivalency. And I do, so I know that my answer is correct. Go ahead and check Google Classroom so you can see what you need to do now.